Okay, as usual, I will just take something. If I am just repeating this in is that direction, I can put some 3 and then 4 meter link steps open base. Okay, so general support as usual, fixed support. Go to the front view, select the things, and then assign to selected nodes. Assign. So ensure that. So then we can go to property define. So I will go for rectangular property of 0.35. Assign to view. Okay. Now what I need to do means like I need to go for loads and definition. Okay. Where I need to go for definition. In the definition, we have something called a reference load definition. So in that case, you need to define first and then we can assign the load. Okay. So in that reference load definition, you can add, see, it is something coming with the gravity, right? So you can take gravity or mass, something like that. So reference load case one, add. Once you add it, you can again add. So that sulfate and all it used to come. Okay. So you can take only y-axis or all three axes. It's up to you because sulfate in all direction. Maybe for seismic analysis and all you can take, right? So now I'm considering only one direction. Assign to view. Okay. Now immediately here you can go to so you here you can select the mass also and you can put the name you want, like you can add. So now we are assigning the reference load. See, here we have sulfate, right? We did something before in the reference load definition itself. So you need to go something like a repeat load. In the repeat load,
Sorry, excuse me.
yeah.
Sorry, can you just please repeat the that part? I got a little confused. Where did you add the mass and everything?
Yeah. Okay. So in the reference load definition, we can add something, right? Once you add, you will get something reference load case one. Okay, this one. And after in that you can click and you can add something so that you can able to add the sulfate. As usual y
Okay,
direction minus, and then I am assigning. That is in the definition part. Now I am coming to the load
okay,
case and I'm adding something, but not dead load live load, but here I'm selecting mass, otherwise you will get some warning or error. That's why I'm choosing
yeah,
mass. You can choose mass or gravity, something like that. So I added something, so that load case one. Now here I'm going to add the reference load.
okay,
Okay. So here the reference load, it will be in repeat load. So repeat load, click that, you can select the second option and you can select this and you can keep it this way. So factor only one, I'm considering add. Okay, so this way, so the reference load getting assigned to the structure. Okay, now what I can do means like I can go to analysis and print, I can put all. Okay, and after that you can also go for post print. Can you see analysis and we are just putting from analysis, see define commands and I'm putting right, but now I'm going to post print. In the post print command, you can also go for define commands. So little bit like you feel difficult, but once you get the things, then it will be easy. So post print, I'm going for DiaCR, I'm going to add so that you will get the print DiaCR command. Okay, after doing all these things, now you need to go to general and go to spec. So here it's something related to the nodes. So it is something related to the floor diaphragm, right? So nodes. all like compressing the floor. Okay, now like you can put the floor level 1 and the height of 3 meter, na 369. So first I will put 3 meter, and I'm asking the software to calculate by itself. Okay, you will be getting a rigid diaphragm. Okay, and it will calculate a master node by itself depend on the floor level. Again, I'm going for node, and I'm going for floor diaphragm, and I'm putting second level, and you need to go from 369 like that, not from 963. Okay, so now I can go for 6 from lower to upper, it's better. Okay, again another also I'm putting. So now we can put the number 3 for a floor level 9 meter. Uh, we can also select by Y range, but I'm putting, since we know na 333, that's why I'm putting directly height. Otherwise, you can put the Y ranges. Okay, so instead always Y upright. That's why here in this floor level Y range is coming. But if you're changing that to Z up, you will get confused here, because here it will not change now. But we can customize this for Z up. So in that case, you need to be careful. Always Y up uh, better when you're working with stat. So 9 meter, I'm going to add. Okay. So you can able to highlight that, and you can see it is also highlighting based on that particular level. Okay. So you can see it is also highlighting the particular level, and you can see it's correct now. So this diaphragm, see, this floor diaphragm should be given or assigned only after the loads and all. So if you're doing this before and putting the reference load after, you will not get the analysis. Okay, now you can directly go to analyze. See, now we are getting zero error, zero warning. If you are doing the sequence wrong, you will get a many error, many warning. It's supposed to be like this. View output file. Okay, so okay, it doesn't matter. Just showing some notes. Okay, see, mass model formed will be used in seismic kind of analysis. Okay, that's why we selected mass, na, not dead load, live load, and all. That's why it's showing. So now you can see the floor diaphragm. See, you can see for each floor level, you can see the floor weight. See, why we are getting floor weight more in 3 meter? Because all the upper floor weights also it will come into this, na. That's why. But in the 9 meter that level, we have less floor weight because there is no upper story there. So that's why it was less. And you can see the center of mass where it will act. And you can also see the master joint number. Okay. Okay, that one we can come 57, 58, 59, right? But we don't have 57, 58, 59. Okay, that is an imaginary point where the mass acting, center of rigidity acting. Okay, okay, that one you can see here. So X, Y, Z, right? 5 comma 3 comma 6, where you can able to put, and you can also see the CR. See, this is what I'm trying to say. 5 comma 3 comma 6, and then 5 comma 6 comma 6, where the center of rigidity acting for each level, each floor. Okay, if I'm putting 5 3 6, where it will come, we will see. 5 3, actually it's supposed to 3 and then 6. Can you see it is in the top view? Can you see it is exactly coming in the center? That's why it is imaginary point where it is finding automatically the center of rigidity. Got it? So that is for that level. And then we can also go for 5 6 and 6. Now this time deleting 5 6 and 6 also, it will come in the same point, but you can see here it is coming here. Okay, exactly in the center it's coming, and then 5 9 6. So you can see that this is how you can find the center of rigidity. Okay, now this I'm deleting. Okay.
In what cases do we have to find this like center of vegetarian?
When you are analyzing, maybe in future, like you will get this kind of things in your stat file. So you can, since you know the concept of reference load and all, right? So it will be easy for you. Mostly for seismic analysis kind of things, they will do this one.
Okay.
Okay, if it is not rigid, then the building will be collapsed, right? Like you must have a floor diaphragm for each and every floor. So I think I can delete. See, I can delete the node here, right? Then no need to worry. See, I can just delete this node. I'm just putting to make you understand how it works. So we need to close this one. Now I can close this one, then we can delete. Why? Okay, one node will be deleted. Since we did something right, again I need to analyze. Now you understand the concept of center of rigidity, right? Okay. So where you can able to see the floor weight. Why? Uh, See, we did something and then we analyzed, right? That's why it's not coming correct. So, but you got the concept right. Since I did something and again I'm doing, that's why it went wrong. Okay, since I did some node, right? That's why it's not coming. But if you want to know the CG, like yesterday I was telling, right? You can go to print CG command. Actually, we got the output before, right? Now because it is not coming because we did some correction and then we are doing, right? That's why it's not coming. But what about CG? It is showing the CG or no? CG also not coming.
What about the weight as well?
What happened?
We are looking for some weight also, right? For the
Yeah. Actually, the output itself not coming now since we did something. So that what we can do means like we can go to spec, we can go to node. Uh, Actually, see all the spec it's gone. You can see here it is gone. Okay, so again I can add it. It is telling you should put in ascending order. This what I was telling you need to go from below. Okay. Because we added something and we deleted, right? That's why it's got confused. Okay. Now I can analyze. Now I hope I will get the output. where we can see all DiaCR and DiaCG center of gravity. See, now you can see the results. See, now the
So
see
what was the issue?
the issue because we did some node, right? The software got confused. We deleted it and we not put the diaphragm again. That's why. So sometimes we need to understand what happened. See, now you can see the total self weight, and you can see the total self weight and total center of gravity of the whole building. This is not based on the floor level. That's what the difference between center of rigidity, that is depending on the floor diaphragm, but center of gravity is depending on the whole building, X, Y, Z of the. Like you can see the whole weight, it's acting on the center of gravity. Okay, but diaCR is different. This we seen right already, and you can see the floor weights and all in the floor diaphragm. So very simple, but if you are doing in a sequence way, then it is easy. Otherwise, you will not get the results. And this master joint number, it's like imaginary node. You can see. That's what I'm trying to show there. X,
So
Y, Z.
floor weight here.
Yeah, this floor
So
weight, it's acting on that point. See, 375.22, it's acting on 5 comma 3 comma 6. Correct, right? Always the whole weight of the structure, it will act at one center point. Yeah, this is normal. Okay. So anyone have any doubts in this? You can practice at least once, then it will be easy for you. Okay. And these things also like very rare, like in the real time scenario, because only for some analysis they will study these things.
what are the like basic things that like in the real time are used like
Real time.
sp-
See, real time they will have a wind load, seismic load, everything they will have that we are going to learn also. But this is something additional that you have learned today.
yeah,
Okay.
yeah.